Hey everybody, we're going to try to wrap up 12.2 notes today, and then there's a worksheet titled 12.1-12.2b that you can just try the odds on that kind of go with this notes page here. So we talked in the last video on radian measure and angle measure, and what we're going to be looking at here today is how you calculate the length of the arc for a certain section of a circle. Okay, the formula itself is actually pretty simplistic. Okay, the formula is S equals R theta. The S is just a symbol that we use to represent the length of the arc. And so when we talk about arc length, we're talking about if you were to straighten out like that curved part of the circle and like lay a ruler against it and kind of measure out what that distance would be. That's what we mean by arc length, okay? And obviously that differs depending on what angle we're talking about. For example, in this little picture here, if I were to draw a 30-degree angle, well, then the arc length would be, whatever this curved part is here that's intercepted. Okay, so that's what we're talking about when we say arc length. So the arc length obviously depends on what the radius of your circle is, and so that's what the R is. And then the theta symbol is your angle, but here's the important part to this. When you are plugging the angle measure into the formula for theta, it has to be the angle measurement in radians. Okay, never degrees. Okay, never degrees, always radians. Okay, be careful about this. Okay, and so we'll be able to practice just a couple problems here. You'll be able to see this. Okay, so in this example, we're talking about monster truck and the tires of a monster truck, which are usually pretty large. Okay, it says here that the radius of tires for this monster truck are 33 inches. Okay, that's a really big tire. The question is, how far does a monster truck travel? Now, notice here it says in feet, after it's just rotated 3/4 of a tire rotation. So it hasn't even made one full cycle of 360 degrees, but it's just rotated 3/4 the way around. How far would it have traveled in feet? And so here's what we want to do. We're going to worry about converting it into feet at the very, very end. What we're after is we're trying to figure out, okay, well, if this rolls 3/4 of a rotation, basically that's kind of what our intercepted arc is, and you could go either direction here. But we're looking at basically going around 270 degrees. Maybe I'll make it go the other direction here. Okay, we'll see. 270 degrees this way here. Okay, we want to figure out, well, how many inches would that be? Okay, so I'm going to go ahead and write down our formula, S equals R theta. Okay, this is for arc length. That would be that yellow part I highlighted. Okay, I'm going to fill in our radius we're given is 33 inches, and then what I need to fill in here for theta needs to be this angle measurement, but it has to be the angle measurement in radians. Okay, it has to be in radians. Okay, degrees are just a little bit easier. You can see in this picture over here to the right that if we were to rotate 3/4 the way around the circle, we can see that would be 270 degrees, something we would probably know, but we don't have the radian measures memorized. And so even though I have them listed here on this picture, what you need to really know is you need to know how to convert from degrees into radians and vice versa. Okay, so if we can say 3/4 is 270 degrees around the circle, and then we want to convert out of degrees, so I'm going to put a degree symbol down here so those units will cancel, and I want to get into radians. We know that 180 degrees is the same thing as 1 pi radians. Okay, because halfway around the circle is 1 pi radians, and halfway around the circle in degrees is 180 degrees. So these degree symbols are going to cancel. I'm going to punch into the calculator, not the pi symbol, but 270 divided by 180. I'm going to switch that back into a fraction. I see 3 halves, and then I'm going to reattach the pi symbol. So technically 270 degrees, you can see this right here in the picture, which you're not going to have this picture to look at normally, so that's why you need to be able to convert, is 3 pi over 2 radians. So that's what I'm going to plug into the formula right here. Okay, Now, when we type this in to actually get how far that this monster truck traveled, you can go ahead and type the pi symbol in. So now you would enter 33 times 3 pi divided by 2, and that roughly comes out to 155.5 inches. Okay, but the question was, how far did it travel in feet? Okay, so what we now need to do is we just need to do a little conversion here. If our answer is 155.5 inches, and we want to get out of inches, you need to put the inches label down in the denominator so that those will cancel each other out. We want to get into feet. Okay, so we need to put numbers in front of this. We know that 1 foot is the same thing as 12 inches. And so what we would type into the calculator would be 155.5. We would divide that by 12, okay? Because when you multiply fractions, it's like we're just connecting this as one big fraction here. Okay, this is going to come out to exactly 13 feet. That's how far the truck would have rolled with 3/4 of a rotation of its tire. Okay, let's try another one here because that one was a little bit tricky here. Okay, here in this example, we are told a circle has a diameter, be really careful, that's not a radius, the diameter of 9 centimeters. So if we want the radius, we need to cut the diameter in half. So the radius is technically 4.5 centimeters. It's asking us to find the arc length if a central angle is 60 degrees. Okay, so in other words, if I were to draw a 60-degree angle, what I'm trying to figure out is how much of the circle is being cut off by that 60-degree angle. And so I'm going to use my arc length formula, S equals R theta. I'm going to plug in for the R, the radius, okay, not the diameter. And then I'm going to plug in for the theta symbol, the angle, but it has to be in radians. Okay, notice in this problem, they gave us the angle, but they gave it to us in degrees. So off to the side, I'm going to convert from degrees into radians, okay? And the numbers I fill in here is very similar to what we did right here when we were trying to figure out in front of feet and in front of inches. We want you to put numbers so that, you know, how many of our feet we're putting here is the same length as how many inches we're putting here. Well, we could say, you could either put 2 pi in front of radians, in which case you would do 360 in front of degrees, or you could do pi in front of radians, and then you would do 180 in front of the degree symbol. Okay, either one works. Okay, we're going to cancel out these degree symbols. Okay, I'm going to leave this with the pi symbol in initially, so I'm just going to type 60 divided by 180. I'm going to switch that back into a fraction. I see 1/3 on the calculator. Reattach the pi symbol. 60 degrees, same thing as pi divided by 3 radians. Okay, then on the calculator, I'm going to multiply 4.5 times pi divided by 3, and I see it's 4.7. That's going to be labeled centimeters. I don't have to convert anything. That is the length of the arc if we were to straighten that piece out that's being captured by a 60-degree angle in that circle. Okay, all right, let's look at one more of these here. Okay, here we got another circle. Again, they're telling us the diameter is 7.5 inches. So if we want the radius, we need to divide the diameter by 2. That's going to give us a radius of 3.75 inches. So I'm just going to put that on my picture here so we can see this nice and clearly. Okay, it says find the arc length of a central angle. Oh, they were really nice to us here. They gave us the angle in radians, which is what we really want it to be in anyhow when we're finding arc length. So we don't need to convert at all. We're going to plug in for the radius, 3.75. In for the theta symbol, 5 pi divided by 3 radians. We're going to multiply that all together on the calculator, and we end up getting that the arc length is roughly 19.63 inches. Okay, now if you remember, I think it was the last section, we were talking about positive angles and negative angles and how there are coterminal angles, which are basically 2 or more angles that if you were to graph them, they land in the exact same spot. And what we did with degrees is we said, look, if you just add 360, every time you add 360 or subtract 360, the angle lands right back on top of itself, and so you get all of these coterminal angles that are the same. Okay, here we're asked to come up with one positive and one negative coterminal angle, but notice the angle we're given is not in degrees, it's in radians, and we're going to leave it in radians. Okay, but you got to think to yourself, instead of adding and subtracting 360, because that's for degrees, okay, we are going to add and subtract 2 pi, because that's really going all the way around a circle in radians, okay? So I'm going to add 2 pi to 3 pi over 2, and then I'm going to subtract 2 pi from 3 pi over 2. Now, when you do this, though, on your calculator, you are not going to enter the pi symbols, okay? Kind of treat it like you would x's. If I asked you what's 3x divided by 2 plus 2x, you really only add the numbers. And so on your calculator, you're going to add just the coefficients, like the fraction 3/2 plus 2, then switch that back into a fraction. You're going to see 7/2 on your screen, but reattach the pi symbol onto the answer. Here would be a positive coterminal angle to 3 pi over 2, and then we're going to do the same thing, subtract like 3/2 minus 2, on the calculator, switch that into a fraction. I'm seeing negative 1/2, but then you would attach the pi symbol back onto the numerator, okay? It's a little weird to talk about angles in radians. We're just not as familiar with it, and it's just kind of odd. We're definitely much more comfortable with degrees. But when we move into the unit circle, we do need to be comfortable with radians here, okay? So at least the idea that if you go 2 pi in either direction, add or subtract, you've gone like one full rotation. Okay, so let's try this last one here. We are going to, again, just take our given angle, 5 pi over 4. We're going to add 2 pi to it, and then we're going to take it and we're going to subtract 2 pi from it. On the calculator, I'm only typing the numbers in. I'd like you to stay away from decimals, so if you could use that fraction button and switch things back into fractions, that is what would be the best way to do this. And then reattach that pi symbol back onto your answer, okay? You can either write it in the numerator, or you can write it like right next to the fraction. You know, either way is fine. It's the same difference there, okay? All right, so what we're going to do here for the assignment is we're going to just do the odd problems on the worksheet 12.1-12.2b, okay? And you can hang on to this. You'll be given the due date for this. It's not going to be Monday, but go ahead and try to practice some of these and see if you can't do this arc length formula and some of those coterminal angles. Okay, again, hope that you guys are doing well, and we'll talk to you soon.